We are on question 7 of this paper, and 7.1 says, a survey conducted in December 2015 determined that 5.7 million South Africans were living with HIV. The researchers used a model of exponential growth, which is A is equal to 1 plus I to the power of n, to predict that there will be 6 million people living with HIV in December 2022. Okay, so we're starting at December 2015 and ending at December 2022. So the question is to calculate as a percentage the annual rate of increase that the researchers used for the 7 years. So firstly, in December 2015, we have 5.7 million people, right? And so these are the people living with HIV. And the researchers, they use this model and then they find out that it's going to grow. Okay, the amount of people will grow exponentially. So they already gave us the formula. So you can see that this is a growth formula. Okay, it's the compound growth formula we're just going to use. So we know that we started here, meaning that's going to be our principal amount. That is the 5.7 million, which is 5,700,000. And then the A value, they already gave us that. They told us that they predicted that there's going to be 6 million people, okay, at the end of December 2022. So that is the A value. That's how much we end off with, 6 million. And then they also tell us the years, okay, the annual rate of increase that the researchers used for the 7 years. Okay, so they also tell us that. So n is equal to 7. And what they basically want us to find is I. Also, just remember, they say that this is an annual rate increase. So it's not compounded monthly or semi-annually or quarterly or anything like that. So this is all we're really just looking for. So we can substitute it into our formula. So we are saying that we have 6 million is equal to, then we have 5,700,000 and then multiply by 1 plus, and we have our interest, which we don't know yet. It's raised to the power of 7. Okay, so this is really the calculation we're working on here. Okay, we can go ahead and divide both hand sides by this 5.7 million. So this will get rid of a lot of these zeros that we have. So this is how we can do that. So 5.7 million, this is now gone on this side. And then we have this. So you can cancel out your zeros. You see, I see 3 zeros here. And actually, you can look at this as 57. And then all the zeros after it, you can cancel it and then cancel the same amount of zeros here. So I see 5 zeros. I cancel those 5 zeros. Then I will also cancel 5 zeros out here. So it means that we really just have 60 over 57. And we can actually treat it like that. So 60 over 57 is equal to, and what's left is the 1 plus I raised to the power of 7. Now remember, we're just trying to get to the I. So we need to get to the I by getting rid of the 7. The only way to get rid of an exponent of 7 is to find the 7th root of both sides. Okay, so when we find the 7th root, I'm going to leave that like that so that I don't have to work with decimals. What happens here is this breaks open, and now you have a 1 plus I is equal to the 7th root of 60 over 57. And then we have the 1. Okay, that is the last thing stopping us from getting to the I. So we can take that over. So really, I is really equal to, because you're taking the 1 over. So you still have this here, right? It is the 7th root. I don't know how I changed that to a 6. Okay, the 7th root of 60 over 57 and then minus 1. Because remember, that just comes over. So it's still this minus 1. That is what's equal to I. Okay, then we can just find this, put this onto the calculator and find out exactly what this is. So on our calculator, it is 0.00735, right? And then also just remember that they specifically asked for the annual rate. So they want it as a rate. Rates are always in percentage. So if it is a percentage, of course. So we're going to go ahead and multiply this by 100. So we're taking everything that we got and we're multiplying it by 100. You could use brackets. You could have also just said ounce multiplied by 100. It would also still work out. Okay, so I'm taking all of that and I'm going to multiply it by 100. And that is the answer that we get. So this is a decimal, but as a percentage, the rate is this. It's going to be, therefore, the rate is 0.74, because that rounds up. The 5 goes over. So it is 0.74% as an annual rate. Okay, so that is the annual rate. So that is it for that question. Moving on to the next question. Okay, so we're on 7.2, and 7.2 says, Shimi invests 4 million rand into an account earning interest of 6% per annum compounded monthly. Okay, so she invests this amount, right? And the interest rate is 6% and it is compounded monthly, okay, per annum, compounded monthly. She withdraws 30,000. So she takes this amount out, withdraws 30,000 per month. Let me just stick to one color. And then they tell us that her first withdrawal is exactly 1 month after she deposited the 4 million. Okay, so how many withdrawals of 30,000 will Shimi be able to make? So I think here, well, something that would be a big hint here is the fact that they are mentioning that her withdrawal is exactly 1 month after. When we hear things like that, 1 month after, it usually has to do with either present value or future value. Now, the thing about it is, if it was future value, for example, future value is for savings. If you're taking money and you're consistently saving money every month or every quarter, then that is future value because you expect your money to continue growing as you are saving more money every month. But you see that in this scenario, that's not really what happened. What happened is she had 4 million and then she invested it into an account that was earning interest of 6%. But then what happens is that she starts to withdraw 30,000 every month. Okay. So instead of it being future value where you're saving money, you're putting money every month, she's actually taking money out every month. Now, what does that actually remind you of? If you said present value, that would be correct. Okay. In this case. So that is really present value because what's going on here is it's kind of like she and the bank are switching places. Normally, with present value, I know that present value is specifically for loans, right? It's really loan repayment. You're paying back a loan. So the relationship really works like this. It's between you and the bank, right? Someone borrows money, or let's say you borrow money from the bank. And so what happens is the bank had money, but they gave you the money now, right? But the thing is, the money is yours to use for now. Sure, you have to pay it back with interest as well. So you owe a specific amount. So in this case, that's like 4 million that you owe. And as you pay back this money, it gets deducted from the amount you owe. Very similar to what's going on in Shimi's case. She has money already, right? She's investing it into the bank. So what's actually going on is like Shimi is behaving as if she's the bank. She is basically loaning the bank money. Okay, she's taking the money and she's investing it into the bank. So she's giving the bank money. And what she's going to be doing is deducting the 30,000 rand every month. Just like the same way a person would be paying the bank back 30,000, right, every month, then it will make their loan smaller. So I shouldn't even say plus, I should say minus because it's something you owe. And when you pay it back, it gets smaller. You pay back more, it gets smaller. So that's really what's going on here. She has money, but she's going to be withdrawing 30,000 every month. So it's really a situation of not really loans, but we're going to use present value here because that's really how it is working. It's like she and the bank are kind of like switching places. She's borrowing money to the bank this time in the form of an investment. Okay, so let's go ahead and see what this is going to look like. So remember that the present value formula is X multiplied by 1 minus 1 plus I raised to the power of negative n and then all over I. And remember, this is in your formula sheet. Okay, so the present value right now would be, that amount would be the 4 million. Okay, so that's what we have there. So I only explained it as she being the lender to the bank because it would make more sense in the context of present value. So that is the 4 million over there. And then the X amount. Remember that the X amount is usually the monthly installments that the person is paying, right? So that they can clear off their loan. In this case, so you can actually see the X as the money that you keep on putting in to eventually finish this amount, to eventually finish the loan. Shimi right now took 4 million and put it inside the bank. She's going to keep withdrawing how much every month? 30,000 every month. That is the money that's going to help this money to decrease and eventually become nothing. So we can see that now as our X value. So that is the 30,000 that we have there. Okay, and I'm going to take that and say 1 minus 1 plus, and then the interest, it's 6%, but remember it's compounded monthly. So 6% as a percentage, remember that is 6 over 100. And if you simplify that, you will get 0.06. Okay, and then we're going to have to make sure that it also takes that compounding, that monthly compounding. Compounded monthly means you need to divide it by 12 because this is a yearly interest that she's going to gain, right? In the year, she's going to make 6%, but then it has to be broken up into months. So that's why we divide by 12. So we have 0.06 divided by 12. And then we have the to the power of negative n. Now the n is the amount of withdrawals, because they're saying how many withdrawals of 30,000 will she be able to make? So will she be able to make until she doesn't have any money left? Kind of like in the situation of a loan. How much payments must you make until you don't owe anything left? Okay, so that is going to be empty, negative n. We don't have anything there yet. And then this still goes over the interest, which is 0.06 over 12. Okay, so this is what we have, and we really have to focus on finding the value of n. Okay, let's go ahead. So we can just work on simplifying things so long so that it's just not too complicated. First of all, I don't like leaving these like that. So what I'll do is I'll put that as 1 plus 0.06 over 12 on the calculator so that I can find out what that is as a fraction. It's just easier to work with as a fraction. Okay, so that amount is actually 201 over 200. So that's actually easier to work with like that. Okay, so when we're actually simplifying, what we're going to do is we can go ahead and divide. Now, because I already wrote this, I'm just going to go ahead and simplify from here already. You see this is your numerator and that's your denominator. Because they're being multiplied, okay, this is being multiplied by that, and they have a denominator, what you can actually do is allow the 30,000 to take that denominator. In other words, I'm saying 30,000 divided by that denominator. So that's really what we're going to find out first of all. And when I do that, I get 6 million. So we have 4 million. Just keep count of the zeros. That's really it there. And then we have 6 million because that's 3 and that's 3. And so our 6. Okay, so 6 million that we have over here. And then we open our bracket and we have 1 minus and then 201 over 200 to the power of negative n, close bracket. Now we can get rid of this 6 million because it is what we need to get rid of to get closer to the negative n. So we can divide both hand sides by that 6 million. So you can just go ahead and say we're going to divide both sides by the 6 million. I'm just going to copy and paste. It's just easier to write like that. So divide and divide. And then let's see what we get. Now, remember how we canceled out when we were dividing in the previous question. The zeros also cancel out. See, we have 3 zeros, 3 zeros, 3 zeros, 3 zeros. So your answer here is just 4 over 6 that you have. And of course, 4 over 6, they both have 2 as a common factor. So divide by 2 is 2, divide by 2 is 3. So that's 2 over 3. So that's what we have there now. 2 over 3, finally. And then over here, your 6 million cancels. Then you're left with 1 minus, and in brackets 201 over 200 raised to the power of negative n. Okay, so at this point, you see, we're trying to solve for this. Do you see that its base has a negative in front of it? What we can do to just make this simpler is take this over so that it becomes positive. So now we have 201 over 200 that is now positive raised to the power of negative n. That does not change the sign of the negative n. This is an exponent, so it's different. And then you have 1 still on the right hand side, and then on the left we're taking that 2 over 3 over. If you say 1 minus 2 over 3, it's like saying 3 over 3 minus 2 over 3, which will give you 1 over 3. So this is what we have. This is our equation. And we need to solve for this. We're really just trying to solve for n. So if you're trying to solve for n in this equation, because n is your exponent, the only way you can solve for n is by using log. Okay, so we're going to say, to solve for that negative n, we'll say it's equal to log of the value that we have, which is the 1 over 3, and our base is going to be the base that was carrying the exponents. So our base is still the 201 over 200, and what we are logging is the 1 over 3. Okay, so this is what we have. So we just put that on the calculator and see what we get. Okay, and so negative n is equal to negative 220.27, and I'll just leave it like that because we have to now get rid of the fact that this is negative. It shouldn't be negative, it should be positive. So you can multiply both hand sides by -1 to make it positive, or divide both hand sides by -1, that's still fine. So it means that n is equal to positive 220.27, right? Now, focus on what the question asked. The question is specifically asking, how many withdrawals of 30,000 Rand would Shimmy be able to make? Okay, so if you think about that, this is 220.27. But think about that 0.27. Is that really a full 30,000 Rand? No, it's not a full 30,000 Rand, okay? It's less than 30,000 Rand. That's what that 0.27 stands for. But the 220, that is full 30,000 Rand withdrawals that we have there. So the total number of 30,000 Rand withdrawals would be 220. So I'll say 220 withdrawals. If you like, you can also say of 30,000 Rand. Okay, so that is it for that question. And we move on to the next question. Okay, so 7.2.2 says, how many withdrawals will Shimmy be able to make if she changes the amount withdrawn per month to 20,000? Okay, so we're just changing the 30,000 to 20,000. Substantiate your answer. Okay, so we also have to give them some sort of reason, and this is for 3 marks. Remember that this was for 5 marks. So it means don't go stress yourself and start from overs. Just start from a point that you can actually just simplify that. Okay, yeah, we don't really have a choice here. We just have to start from here because at this point we had already substituted the 30,000. So I'm going to take this as it is, and in place of 30,000 I'm just going to replace 20,000 instead. I'm going to replace it with 20,000. So we have this, and that now is going to be 20,000. So let's see what's going to happen here. Okay, so again, we have to divide. So let's take that 20,000 and divide it by the fraction that we have. So we're taking 20,000 and we're saying divided by 0.06 over 12. Okay, that gives us 4 million like we have here. So we have 4 million here is equal to, and we also have 4 million here as well. And then open bracket, what are we left with inside? 1 minus, still the same thing, 201 over 200, and then raised to the power of negative n, close bracket. Okay, if you divide both sides by the 4 million, you're really just going to get 1, because 4 million and 4 million just on both sides really. So those two cancel out, and here we're going to have 1 is equal to, that cancels. It's technically a 1, but it's like 1 times everything here would stay the same. And so you have 1 minus 201 over 200, all raised to the power of negative n. Okay, so we just have to simplify this and try and solve for n here. So in this equation, okay, what we have, you can still do that whole thing of taking that over to make it positive. You'll be left with 201 over 200 raised to the power of negative n is equal to, but now you have still that 1 on the right hand side, and on the left you also have a 1, so we can take that over and that will become minus 1. And so this is 201 over 200 to the power of negative n is equal to 0. Okay, so now looking at that is equal to 0. Is that even possible? Because what we're actually doing is we're taking, it's kind of like you have a base and you're raising it to an exponent and is equal to 0. That's not possible, okay? Because the thing is, if this is an exponential function that we have, you can't really raise it to any number that is going to give you 0. And the thing about is the base specifically is not 0, okay? the base has a value. Look at the base. The base is 201 over 200, which is a proper fraction, which is a number that is bigger than 1. Our base is greater than 1. So, for example, if you said 2 to the power of a specific number, is it ever going to give you 0? Never. Even if you use a negative number, even if I say 2 to the power of negative 1, it's going to give me a half, which is a positive number. 2 to the power of negative 2, it's going to give me 1 over 4, which is also a positive number. Okay, so we're going to have to look at this differently. So let's actually think about how we can solve this, because right now, this would not really have a solution. It doesn't have a solution, but we can also look at it from this angle, because we need to really just tell them the amount of withdrawals. There's definitely an amount of withdrawals. Maybe it's not specifically countable, but there is an amount of withdrawals because we know that there is money that's being taken out every month. Okay, so let's think about it like this. If we were looking at this and really just trying to solve for this exponential equation, right, where we have b to the power of x is equal to 0, that kind of equation would look like this. Because it's b to the power of x and you know that your base is greater than 1, right? It's kind of like numbers like 2 and 3, the numbers that are not fractions in the sense that they are improper fractions like 1 over 2. They're not numbers like that. Okay, so the kind of function that this would form is an exponential function. Okay, I'm trying to solve it looking at it as a graph just to understand what's going on. So if we have a graph that does this, okay, first of all, we know that there's an asymptote at y equals 0. Okay, meaning that y value of 0, this here, okay, this graph will never touch it, meaning it's never really going to have a value of 0. Okay, but we can also look at the fact that, please also remember the function we're looking at is this one. I'm just actually building this up just because it is an exponential function, and I'm just trying to show you what that actually looks like. So naturally, an exponential function that has b to the power of x is equal to 0, where b is greater than 0, it would normally just increase like that. Okay, so with this function, what we can do here is make it look like this one. Okay, we already have our b value being greater than 0. That's great. But you see that next to n, they multiply by negative 1. We can also do that here. However, that's going to cause something to happen with our graph. If you multiply your x values by negative 1, what you're actually doing is you are actually reflecting this graph in the y-axis or through the y-axis. That's what you're doing. Okay, so if we are reflecting that in the y-axis, it's just going to form a mirror image through the y-axis like that. So it's going to really just look like this. So this is actually our graph. That's what our graph should look like. Okay, b to the power of negative x. And then it fits to this one. It really just looks like that. So we're trying to find out what our solution should be if we're trying to make this equal to 0. So if we were trying to make it equal to 0, this is what would happen. Remember, being equal to 0, that refers to the y values. Okay, I could say try to make this equal to 1. Then I'll just look for all the places on this graph where it has a y value of 1. And then I'll answer them like that. I'll say the x values, for example, let's say 5. Okay, it's not actually 5, but that's just an example. And in this case, we're really just trying to find out where's the y value equal to 0. Now, we can see that it actually doesn't end up becoming 0. However, do you see that if you are looking for the places that are at least close to 0, that have y values that are close to 0, okay, you look at it like this. You see, if you look on top, these values are positive. These values are not close to 0. We're trying to look for y values that are close to 0. If you keep going down, okay, look at the graph here. For example, let's say here. Look at where this graph is. Its x values here, okay? And as we get closer to the y value of 0, look at where the graph heads towards. Okay, look at the x values of this graph. As you get closer and closer to a y value of 0, your graph, your x values of your graph are moving towards the right-hand side. Now, we know because it's an exponential function and there is an asymptote here, it will never actually become 0. However, as we approach 0, okay, our x values move closer and closer to positive infinity. Do you see that? Okay, so with that, The way we can answer this question really is like this. For this expression, I change that to 0. For this expression to be equal to 0, you need to take n values, okay, that move towards positive infinity. So for this equation, okay, not even just this one to be equal to 0, our n value needs to move closer and closer to positive infinity, or should be positive infinity, should be heading towards positive infinity, because that's the only value that helps us move towards a y value that is at least close to 0. It may not reach 0, but it's close to 0. So in a nutshell, I'll really just say that n, the answer for n in the context of this question, because they specifically want us to tell them the amount of withdrawals per month. I'll tell them that there is an infinite amount of withdrawals that you can make, okay, in this. Okay, so there is an infinite amount of withdrawals of 20,000 Rand that Shimi can make. And I actually want to show you how this is going to work out if we're looking at it like this. So remember that Shimi had 4 million Rand, right? So 4 million, that's how much she starts off with. And then she invests it into an account. And she's going to be withdrawing 20,000, okay, in this 7.2.2. She's going to be withdrawing that amount. So let's look at what happens. You see, this money is being put in here, invested at a rate of 6%, okay, per annum, but compounded monthly. So we still have to divide it by 12. So what happens is when the money gets invested, 1 month later, she's going to withdraw 30,000. But this 4 million will not be 4 million anymore. Remember, it's going to gain interest. So because it's going to gain interest, we're going to take that 4 million and we would multiply it by the amount of interest it's going to make. And of course, remember that the 4 million and the interest is going to be here. They're both going to be here. So how I'll look at that is by saying 1 plus, okay, 0.06 over 12. The reason why is because I'm saying that the 4 million and the interest of 4 million, okay, 6% is also going to be there. So if you did that calculation, we can go ahead and put that down and see what that gives us. And look at how much will be in her account. The amount in her account is 4 million and 20,000 Rand. And then what happens is when it grows, she's going to withdraw 20,000. So she's going to take out 20,000 and then see what happens now. What is left in the account after she removes 20,000? The 4 million again. And then what's going to happen in the next payment? It's going to grow. That 4 million that she left in that account will grow again at the same rate. So it's going to grow again at 6% again. And so it's really just going to become that 4 million and 20,000 like it did initially. You see, when it grew the first month, it became that. We ended up with 4 million again after her withdrawal. Then it's going to grow again at 4 million. It grows again to this. And then she's going to withdraw again 20,000. And then she will be left with 4 million again. And then in the next month, it's going to grow again to 4 million and 20,000. And then she's going to withdraw. And that's why it's an infinite amount. Because at this rate, okay, if you're withdrawing exactly 20,000, that's what's going to happen in a theory sense. But in real life, they'll probably just calculate this a little differently. They may not maybe use something like present value. Or they may even just make adjustments probably to either the interest rate or the amount that is being withdrawn. Okay, so that is the reason why we ended up with infinity. There's an infinite amount of withdrawals, and I hope you guys could understand that with the way this kept on going. Okay, so that is it for 7.2.2. So we're done with that. And then we finally move on to the last question in question 7. Okay, so 7.3 says, Estrid opens a savings account with a single deposit of 1,000 Rand on the 1st of April 2022. She then makes 18 monthly deposits at the end of every month. So her first payment is made on the 30th of April. You can see on the 1st, she opened the account and put 1,000. Then she makes a first deposit at the end of the month in that same month. And then her last payment on the 30th of September 2023. That's when she makes the last payment. So the account earns an interest of 15% per annum compounded monthly. we have to determine the amount that should be, I need to highlight that as well, okay? Compounded monthly. Determine the amount that should be in her savings account immediately after her last deposit is made. That is specifically on the 30th of September 2023. Okay, let's go ahead and create a timeline so that we can understand what's going on here. I'm not saying this is specifically timelines. I'm just creating a timeline just so that I can see what is going on. So the first thing that happens is that Estrid opens this account, right? And the account has 1,000 Rand. She opens it with 1,000 Rand. So she doesn't just go and open an account. She puts 1,000 immediately. She opens it. Okay. And then she starts to make deposits. She makes 18 deposits of 700 Rand in total every end of the month, right? So the first deposit that she makes, they mentioned, was on the 30th. And I should actually be writing this here. So 1,000 first, and that's on the 1st of April, specifically 2022. Then the first deposit was on the 30th of April, 2022, and that was 700 Rand. And then she continues to make deposits. So after April, May, okay, she's going to also make a deposit there as well. And she basically does this all the way until the 30th of September. That's the last time she makes a deposit of 700 again. So 30th of September. But now we don't have to go ahead and start 2023, of course. We don't have to start counting how many deposits she made because they told us that. They told us that she made 18 deposits in total. So from here, this 700 Rand deposit, okay, she made 18 700 Rand deposits. Okay, so that's how much she deposited. So with this, the question is how much is going to be in her account immediately after this last deposit. So looking at this, it actually follows the basic order of future value calculations because there's no loan happening here. She's depositing money. She's taking a specific amount of money and it's the same amount throughout, and she's consistently depositing that amount every end of the month. So this is future value, okay? So she's saving that money. The only thing that you need to consider is this 1,000. This 1,000 is not part of these consecutive 700 Rand deposits. This one, she puts it immediately she opens the account. So what we can do is actually look at the 1,000 as a separate investment. So that 1,000 Rand, how long will it stay in her account? Well, you're going to have to think about how long this account lasted. The last deposit happens here, right? 700 Rand, it's at the 30th of September. That's the last deposit. So if you count how long that would be, from here, okay, from April to September, that is 18 months. And the reason I'm saying it has to be 18 months is because we have 18 deposits every end of the month. So meaning a deposit in April, a deposit in May, and it keeps going until the next year, September 2023. So that is 18 months that this account has been active. Okay, so that is going to gain interest for, see, 1 and 2 and 3, all the way to 18, and it's not going to go past this because this is where the last deposit is made. So I'm going to calculate that as a separate investment, and it's going to grow for 18 months. Then the other thing we're going to have to think about is we're going to have to think about this as a future value investment because she's taken an amount of money and she keeps depositing that same amount every month. Do you see that she opened the account on the 1st, but only started this consecutive deposits of 700 Rand 1 month after the account was created? So we can actually look at it separately. We can start with the 1,000 Rand and see where this went. So we're going to use the compound interest growth formula for the 1,000 because it was not consecutive deposits. It was just one deposit that she made of this. So that is A is equal to, and we'll say P, of course. Now the principal amount is the amount you invest. That will be the 1,000. That's how much she invested initially. We're going to grow that amount, of course. And it's 1 plus our interest rate. They already told us that. It is 15%, so 0.15 compounded monthly over 12. Okay, raised to the power of, and remember, how long does this 1,000 Rand stay in this account? It stays for 18 months. So it goes to the power of 18. So we'll calculate that one separately and then the other one separately as well. Okay, so I see the amount, but the thing is, because they are decimals, I'll hold on to that. and we'll add it afterwards. Okay, so we can just leave it like that so long. Then we have to calculate the 700 rands. Okay, so this one is the one that we're going to use future value for, because that is the one where she doesn't deposit just one 700. She consecutively deposits 700 rand 18 times. Okay, so each month, 18 months. So for that, we're going to use the future value formula, which is X. And then remember, this is in your formula sheet. We have 1 plus I raised to the power of n minus 1 all over I. So we're going to go ahead and calculate this. So our future value should be equal to our X amount is that 700, because that is your monthly deposits. Then we have 1 plus our interest is, we have our interest over here, 0.15 over 12 raised to the power of how many deposits was made? 18 deposits, okay, minus 1, and then all over the interest, which is 0.15 over 12. Okay, and really what happens is that these two amounts get added. So I would really just add them together. I'll add the amount that is in her account, because really the question at the end just says you just need to determine the amount that should be left in her savings account. So I'll just say amount left in account. So that would be the accumulated amount of the 1,000 being invested plus the future value. So we can really just add those together. Okay, so yeah, I actually wanted to do it as one calculation because I knew that decimals were going to happen either ways. So we can actually do that. So you just have to be very careful on your calculator to just not make any errors. So I'm going to add that whole thing there. Okay, so just be careful not to make any mistakes with this. So let's go ahead and add that, and then we'll see what we finally get as our final answer. But if you just round it off to like at least 4 decimals and then 4 decimals and add it, it should be fine as well. So you can also do that. You don't have to be worried about that. Okay, so when I add both of them, I get the final answer being 15,282 points, and this is 0.91 cents. And that is our final answer. Okay, so that is it for financial maths for this question. And then in the next video, we finally move on to calculus and then probability.